All right, today we're all going on a quest, not for some lost treasure, but for something way more valuable scientific truth. We're going to master the secret ingredients of any good experiment, the tools that let us find real, honest answers. Let's dive in. So, first, we'll look at the basic recipe for science. But, maybe more importantly, we're going to investigate a crime scene. What happens when a perfectly good experiment just goes horribly wrong? Seriously, think about this for a second. Have you ever baked a cake? Maybe you thought you followed the recipe and it just turned out to be a total disaster? You're just left there staring at this thing with absolutely no clue what happened. And see, that's the problem, right? If you change a bunch of things all at once, maybe you tweaked the oven temp and you used a different flour and you baked it for less time, it's impossible to figure out what actually caused the catastrophe. You've basically created an unsolvable mystery for yourself. And that, my friends, brings us to the number one golden, most fundamental rule in all of science. It's the bedrock of every good experiment. To find the real truth, you can only change one thing at a time. And in the world of science, we have a special name for these things we can change. We call them variables. So, let's meet our allies on this quest for truth. Every solid experiment is built on what I like to call the holy trinity of variables. Getting to know them is absolutely crucial. So, let's break them down. Okay, first up, we've got the independent variable, or the IV for short. The main thing to remember here is that this is the one thing you, the scientist, are changing on purpose. You're testing it to see what happens. Just think of it as the cause in any cause and effect story. Yeah, a really easy nickname for it is the changer. So, for example, let's say we want to test if playing music actually helps plants grow. Well, the music itself, turning it on or off, that's our independent variable. It's the one thing we're deliberately changing. All right, next on our team is the dependent variable, or DV. This is the result you're watching for. It's the data you actually measure. And its outcome literally depends on whatever change you made with your IV. So if the IV is the cause, the DV is the effect. So naturally, we call this one the measurer. Back to our plant experiment, what would be the dependent variable? Well, it'd be the height of the plant, right? We're measuring its height to see if our changer, the music, had any effect at all. And finally, and you guys, this is so important, we have the control variables. These are all the other things in your experiment that you have to keep exactly the same. They are the key to making sure your test is fair, that it's reliable, and that someone else could do the exact same thing and get the same result. I like to call these the fairness police. Think about it. For our plants, if we really want to know if the music is what's making them grow differently, then everything else has to be identical. The amount of water, the type of soil, the sunlight, even the size of the pot. All of it has to be the same for every single plant. If it's not, we're right back to that disastrous mystery cake. Okay, so now that we've met the whole crew, let's see how they all work together. There's actually a formula for finding the truth, a way to get a real, reliable answer to almost any question. So here it is, the secret sauce. It's a simple but incredibly powerful formula. The independent variable causes a change in the dependent variable, while, and this is the most important part, all the control variables stay exactly the same. A causes B,
but only if C, D, and E aren't messing things up.
Let's put this into practice with another classic experiment. Say we're testing if soda causes tooth decay. Our changer, the IV, is the type of liquid. We've got soda versus water. Our measurer, the DV, is going to be the amount of tooth decay we see. And our fairness police, the controls, well, we'd have to use the same kind of tooth, the same amount of liquid, and let them soak for the exact same amount of time. See how it works? Okay, so you know the formula for good science. Now it's time to meet the villain of our story, bad science. This is what happens when those variables get out of control and lead you completely down the wrong path. I bet you've all seen a commercial like this, right? Some paper towel, let's call it brand X, is holding up a bowling ball, and they shout, "It's the strongest!" But now that you're a variable detective, is this actually good science? Let's really break this down. A fair test would be to compare a dry sheet of brand X to a dry sheet of brand Y. The only difference, our one and only IV, is the brand. That's a valid test. But what if the commercial tested a dry brand X against a wet brand Y? Uh-oh, now you've got two differences, the brand and the wetness. That means the whole experiment is totally invalid. And there's the big reveal. That commercial didn't prove their paper towel was stronger at all. All they really proved is that a dry paper towel is stronger than a wet one. I mean, duh. It's a totally meaningless result because they failed to control their variables. Okay, you've learned the theory, you've seen the good and the bad. Now it's your turn. Time to put on your detective hat. Let's send you on your very first mission. So here's the case. A guy named Rahul wants to know if hot water freezes faster than cold water. It's an old question. So he sets up an experiment. He puts 1 cup of boiling water and 1 cup of regular tap water into the freezer to see which one freezes first. Okay, detective. First question. What is the changer here? What's the one thing Rahul is intentionally changing to test his idea? I'll give you a second. Did you say the starting temperature of the water? If you did, you are spot on. That's his independent variable. All right, next up. What's the measurer? What's the result he's actually going to record to get his answer? Think about it. Yep, it's the time it takes for the water to freeze. That's his dependent variable. And now for the big one. What are two things the fairness police would demand he keep the same? What are two of his control variables? I'll give you a hint. Think about what else could affect how fast water freezes. Okay, time's up. He would absolutely have to use the exact same amount of water in both cups, right? And he'd need to use the same size and type of cup. If he doesn't control for those, his results are meaningless. And just like that, your quest is complete. You now hold the secret keys to a fair test. Because that's really what science is all about, isn't it? It's the art of controlling the world around us, just so we can understand one tiny piece of it at a time. So now that you have the power, my question to you is, what are you going to investigate first?